Today's webinar will be like more practical than if we compared it to yesterday's webinar. Um, in today's webinar, we will try to do two things. The first thing is we are trying to interact with the Vault dataset for the guys who does not um, have involved with the Vault dataset so far. So like years ago, Equinor just released a full dataset of their field. The field was called Wolf. I think the field is out of production currently. However, they posted the production data and the historical data for for the engineers and the students to practice on and work with it as a practical data set to increase their knowledge. So the data set is actually is very beneficiary. You can do a lot of projects with it. You can drive analysis from it. So it's basically you can use this as a training data set for your knowledge gathering and self development. So what we are trying to do is to open up this data inside Python. So we can see we have a lot of columns. We have dates, we have wellbore names, we have wellhead pressure. So we have a lot of columns, and the amount of data entry in this is almost like 16,000 rows. So Python can handle this for sure. One of the issues with this data is all the wells are on the same sheet. So we need to do something about that. What we can do is plot the production, the water injection process, wellhead pressure. So a lot of things we can do with that. So let's go ahead and start working with the Vault dataset. So before we do anything, it's very useful to start working with another library called Streamlit. Streamlit actually is a dashboarding library that's provided by a company that's called Streamlit. The nice thing about this library is it provides you a lot of charting and interactivity to your data sets. So even you can just build the application and share it with others on the network, so they can view it from their PC without even installing the software. So it's a very nice application. So let me share the main website for the Streamlit library. So this is how Streamlit is written. Okay, so this is basically the documentation for it, different components you can add. So this is basically just something that's similar to Microsoft Power BI. However, this is built with Python, so you need to build it with Python. However, it's very easy to use. It's web based, so it's very nice. You can deploy your app on the cloud. You can just host it yourself on your personal PC. You can share it with your colleagues on the same local network. So it has a lot of features. So we can see you have like text elements, you have chart elements, a lot of chart elements actually. So we will take advantage of that. But before we do so, we will also take another library called Plotly. Plotly is a library that's similar to Matplotlib that we took already got introduced to yesterday. However, Plotly provides a bit more interactivity, and the looks is a bit more appealing to the user, to the end user. So let's go ahead and start. So what we need to do is I've already created a small project file that resides on my desktop. It contains two files. The first file is called main.py. This is the main Python file. And the second one is the Vault dataset that I already show you. So what we are going to do is we're going to import all the necessary libraries we need. So import. Let's just first start to import matplotlib.pyplot. We already saw how to import this as PLT. I'm going to import pandas to open up the Vault datasheet. So import pandas as PD. Okay, so these are just names for you to memorize. So these are the just important conventions. These are rarely ever change. So So it's a convention on the internet to name pandas as PD, and it's the same as for the Matplotlib. These are just conventions. You can name it like a plot or something like PLT2 or maybe PLTE, whatever you like. But the convention is to name it as PLT. Okay, so there is a new library. It's been out in 2020. It's called Streamlit. It's very important library. So we are going to ahead and import that as well. Import Streamlit as ST. Okay, and we're going to import Plotly as well. So import plotly.express as px. So if you go ahead and read Plotly documentations, there's two main methods into creating plots. The first method and the newest one, it's called express. Express actually is a class that's contained in the Plotly library. Express is a class that's new. It's targeted toward the more of beginner people who does not like to code a lot. This class is actually provide you with one-liner codes, a single line that can provide you with nice plots. So this is that, and yes, I think we are already already going ahead. So what we're going to do is we're going to run our Streamlit app. So whenever we update our website or whenever we update our app, the update shows right away. So in order to run Streamlit application, you need at least to write one expression in Streamlit. So how to write Streamlit expression? You just type st dot. When you type dot, there is a lot of options. One of the options is just to add header to your application. So this header is just like a text that's a bold, big text. So this is just like a title, let's say. So let's just name it as Volve dashboard. Okay. So to run the application, the Streamlit application is a bit tricky to run. When you click this run button, actually it does not run. It shows you a very helpful message. Sorry, this is it's called header, not head. It's called header. So the application tells you warning. To view the Streamlit app on browser, run it with the following command. So the command is, it's reading like this: Streamlit run, and then the path to your Python file. So what you're going to do is you need to open the command or the console. So I am going to run Anaconda prompt, which is a special version of the command prompt. So I am going to change my directory to the directory that's provided by the Streamlit app. So I will just copy this. By the way, this is just a one-time thing. You don't need to do that a lot. You only do it only in the beginning of the programming session you're doing. So now I've changed my directory, as you can see. Okay, so hopefully this is the font is much more visible to you guys now. Let me just type the Streamlit command in order to run my application. Just for your information, guys, the name of the file that I am writing my code in is called main.py. So this is very important when you're running Streamlit application. So you just write Streamlit, and then you write the keyword run, and then you put the file name, which is main.py. Click OK, or just click enter and wait for the command prompt to return the results. So you can see now it's showing that you can now view your Streamlit application in the browser. You have the local URL and you have the network URL. The local URL, this is for your development purposes. The network URL, this is you can share it with the other guys who are connected with you, other colleagues you connected with you on the same Wi-Fi network or the same local network. You share this with them, guys. And they will be able to view whatever application you are developing. So they will view it as a user only, not developer. So they will have an access to the view. So this is the application that we already wrote. So you see it's already on the web base. It's showing us this keyword we already wrote, Wolf dashboard. By the way, in order to push updates to this application, what you need to do is just make any adjustment or any modification. For example, I will write another smaller header to the application, and then I will click save, and the application will update itself. So st dot, there's another cool functionality inside st. It's called caption. Caption is a smaller and much finer font. This can be used for captions, for like notes, for information, displaying information about something. So let's say this is done by Streamlit. Okay, so how we go ahead and make the app update, we either you press Control and S on your keyboard, or you can just push the save button in the software. So it's very important to know these are the interaction messages that's already appeared on the Streamlit. So see, there's a message that's already shown. It says the file source changed, rerun always rerun. Just you always select always rerun. This will save you some headache on all, like going update the software every time. So always rerun. Now you have this already appearing. So if you do any subsequent changes, let's say I want to add like 3 dots on the application, just go ahead and Control and S. You see now it's the application is instantly as updated. So let's go ahead and do some useful stuff. I will go ahead and open up the Vault dataset. To do that, you need the Pandas library. So in order to import that, I'm going to create a variable called df. df stands for data frame. As we talked yesterday, data frame is just a fancy name for data table. So pd.read_excel. So you have another functionality called read Excel. So this actually reads from Excel files that you have. So my Excel extension is Volve, the name is volve.xlsx. Okay, I'm already reading this. So in order to output the data frame or the data table you already read using Pandas to the Streamlit dashboard, what you're going to do is you need to use another functionality that's presented in Streamlit, which provides you with the privilege to print full data frames or full data tables. So st.dataframe, okay. You open and close the parentheses, and then you pass your data frame to it. So we'll just save the program. And it's running and it's doing its thing. By the way, I don't encourage you guys to work with Excel sheets with Python. Excel sheets used, actually they tend to get bloaty, and they are already they are already slower to load. If you have the capability to move your files to comma separated CSVs or any ASCII file or any plain text file, please do that, because there's like a lot of speed gain against working with Excel. So Excel, by the way, it's not recommended. So if you have Excel, you can just move it to plain Excel, to plain ASCII file or plain text files. If this is not possible due to multiple worksheets you have, just keep it Excel, but keep in mind it's going to be a bit slower. So this is all the data sets we have. So yeah, this is printing a full data frame in the Vault dashboard. This is not that beneficiary to us. I will just comment this out. You write the hash pound. This comments out your line. So it means it's not going to be executed by the compiler, or it's not going to be executed by the interpreter. Okay. So what we're going to do is we're going to plot the well name, the production of the well versus date. Okay, let's go ahead and do that. So to do that, we need to use Plotly Express. You can use Matplotlib for that as well. There is no issue with that. However, the Plotly Express is much more interactive. So it has this an interactivity features, which is very nice. Let's go ahead and create a Plotly figure. I will call it just FIG equals to PX. PX, we said that PX is the alias or the given name by the programmer, which is me, or this could be you guys, to the Plotly Express, so you don't have to go ahead and write this long name each and every time. So PX dot Plotly Express has a lot of plotting capabilities. For example, you can do line plot, you can do scatter plot. There is a lot of plots you can do with Plotly. Let me just show you guys the Plotly main website. By the way, learning Python actually involves a lot of research from you, from our part or the programmer's part. So you will always keep learning and keep updating yourself with the newest features that's been added to these libraries. So this is the main website for Plotly. By the way, Plotly is now a company. It provides two types of solutions. You have the community built Plotly, which is like a free version of their services. However, it does not have any support. All the support comes actually from the community, from the Python community itself. And the support, by the way, is very good. And there is another version of the Plotly, which is a subscription base. It's the same code. However, they give you like more tools to build faster solutions, but you can just use the free one, which is great, by the way. So if you go to the documentations, so you see there's two things called dash enterprise, and yeah, let's go ahead and go to gallery. The gallery actually shows you all the features they have been building, or the project they built using their toolkits. So the internet connection is a bit slow, but yeah, this is basically their website. So going back again to our programming sheet. So Plotly Express provides multiple plotting functionality. One of the plotting functionality is line chart. You go ahead and type line like this, open and close parentheses. Similar to Matplotlib, you need to provide the X, the Y, and that's it. You'll get your plot. Actually, there's two unique ways to go ahead and do this. The first thing is you can pass the data frame, which contains all the data. Okay, this is the first method. And then you can specify what's the name of the x-axis as a string and what's the name of the y-axis as a string too. So this is one of the ways. So I know my x-axis is going to be the date, PRD. Let me show you the Excel sheet again. So this is the x-axis. It's always going to be the date. And the y-axis can be one of these variables you want to plot. For example, you can plot the average wellhead temperature. Okay, it all depends on your preference, by the way. So let's go ahead and plot the downhole pressure. So I'll just copy this, by the way. So I will set it to y-axis. So the x-axis is going to be the production date, and the y-axis is going to be the downhole pressure. So in order to view this in dashboard or in the Streamlit, what you're going to do is there is a nice functionality in Streamlit. It's called Plotly chart. So you write st dot Plotly underscore chart, and you open and close the parentheses, and then you will add your figure to it. So what this line means is let's go ahead and just review this line. What we did here so far is we created a data frame or a data table, and we read it from Volve Excel sheet. Afterward importing the data frame, what we're doing, we are only taking two columns, okay, two fields in the Excel sheet and plotting those two ones only. So that's basically what we are doing. And then in the line 12, we are doing a command that takes up this newly created chart, which is saved in the variable called fig. Okay, and then we are passing it to a function that's provided by Streamlit. This will plot the Plotly chart for us on the dashboard. So let's go ahead and click Control S to save it. Just wait a little bit for it to refresh. Because we are working with Excel, Excel tends to be slower, by the way. For some reason, it's taking too much time. Let's go ahead and write the same solution by exporting the Vol dataset to just plain text file. We're going to just copy this or copy all the data. Yeah, still not running. So copy all the data. So as the data have been copied, we're going to create a new file. Just any file will do. Let's call it volv txt.txt. Save it, and then you just go ahead and copy and paste your file content in here. So this is the file content. Let's go ahead and click Control S to save the file. Now we have the vol dataset as Excel sheet, as a plain ASCII file. Do not save. Yes. So let's just go ahead and change some of the parameters in our program. We'll convert this pandas to read underscore CSV. Change the file name to volv.txt. Okay. And now just click run. Okay, so we're forgetting one thing, how the file is separated. So SEP equals to separation with tab. Just click save. So I think the Streamlit server is already down. So let me go ahead and rerun it again. So let's go ahead and rerun the Streamlit again. So Streamlit run main.py plotly chart. Okay, just click on run. So yeah, there is this says that Streamlit does not have no attributes plot chart. This means that the function name we provided, plotly chart, it's not correct. So we go ahead and click save. We already changed that. Click save and rerun it again. So it's the same issue persists. Now, after I changed the name of the function, that was a typo, a misspelling there. So you can see now I have my plotly chart. So this is known as the plotly chart, and this chart is interactive actually. You can hover your mouse over it, and you'll get the results. So these are the charts we're having. So there is another nice thing you can do about this is you can add multiple lines to the same chart, or you can add multiple charts with different variables. So what I'm going to do is I'm going to add another chart below the first one, and I will select another parameter or another field to be plotted. So let me go and declare another figure. So I will call it like a figure 2. By the way, when you're working programming or you're programming your custom solutions in oil and gas, it's not recommended to name the functions or the parameters as like this. So this is not a healthy way to name it. You need to name it a precise way. So you would name this like figure underscore let's say downhole pressure. So this is how to name it properly. So I will copy this and just select another variable from the Excel sheet. So let's go ahead and see what variables we have. Okay, so let's go ahead and plot the oil volume. So the oil volume is bore oil vol. How do you know these? These actually you can acquire the knowledge to the names of these things by interacting with the volt data set a lot. So you will get the knowledge to the names of these variables. So I will change the y-axis to bore oil volume. So this is the oil volume rate. And I am putting it in a variable called figure 2. What I need to do is just view the figure 2 below figure 1. How to do so? I'm going to write st dot plotly underscore chart, plotly underscore chart, and then close and open brackets, close and open parentheses, and write fig. This time it's going to be fig 2. So just we'll click save, and the Plotly application should be updated accordingly. So I will just maximize this. So now you have two variables. You're plotting. The first variable is average downhole pressure. The other one is the bore oil volume. So in order to zoom in these types of plots, what you're going to do is just drag your mouse over the curves. So these are the values we have, and it goes the same for the average downhole volume. By the way, the way or the methods we already plotted these, the method is correct. However, it's technically it's not correct, because what the chart is doing is it's averaging, or it's just plotting every value on every well on the same chart. So this is not correct. You have to group the wells in different lines. So if you can see, you have multiple well names on the same Excel sheet. So you need to take that into consideration. So how you can do that? I will just copy the wellbore name and go back ahead to my Python program. In the Plotly Express line or any of the Plotly lines or scatter or bars, what you can do is there is a nice feature. You can color any entry in your chart based on a given column name. So for my case, I will color it based on the well name. So I have specific number of wells. I think it's 7 or 8 wells. I need to color them based on the well name. So this will produce distinct line or distinct series for each well. Let's go ahead and save the application. Okay, so these are the wells that already been shown, but the first well only the well that has the readings. The second one did not change anything because we did not apply the coloring for the second one. Let's go ahead and apply the coloring for the second graph. So underscore, sorry, comma, just write color equals to the column that contains the well names. Okay. So this will group your wells for you. So just click Control S. Now you have your well name shown. There is a lot of things you can do with the Streamlit. For example, you can create radio boxes. You can create buttons with it. For example, to create a button with Streamlit, what you're going to do is let's create a button in the top of the app. So st.button. So this is how you do it. And then you provide a name to the button. For example, let's call it generate plots. So this is one of the ways to create buttons. There is a lot of other elements you can create as well. For example, you can create text inputs or number inputs. So how to do that is you write st dot number underscore input, and then you provide a label to it. Let's say enter reservoir pressure. So this is how to do so. There is another thing you can do with a Streamlit is you can just divide your application into columns and rows. How to do so? You can do it with the command like st.columns. And then you provide the number of columns to that one. So, and you it goes the same for the rows. You write rows like this, and then you just put the number of rows into the application. So this provides you with multiple rows for you to just organize your app the way you want. Let's go ahead and just spice the application a little bit. I'm going to open up my Visual Studio Code. I will try to connect to a SQL database, and then I try to pull some results or some data from the SQL. So let's go ahead and pull up the Visual Studio Notepad. So this is the Visual Studio application, by the way, Visual Studio Code. So this is known as the Visual Studio Notepad. This is actually based on Jupyter notebook. So if you see, it's called Jupyter in here. So yeah, it's based on Jupyter, by the way. So what do we know? What do we need to do is actually in order to interact with the SQL databases. First of all, you have to install the SQL database. So I have a SQL database. This is it. This is called the Microsoft SQL Server. You should have your database or whatever you like. The dataset is installed on the database itself. So this is my database, by the way. This is all the columns it's having. So you should, by the way, to interact with this database, you should know the SQL programming language, or it's not a programming language, it's just a scripting language that allows you to interact with data. So let's go ahead and create a query in this and to view the contents of some of the columns. So I will just try to view the X and Y table. So let's go ahead and select that table. So how do you go about and select all the data inside that table? You write the statement select, and then star means select everything in that table from XY. So you click run by clicking this XU button. Now you get all your data. Sometimes the data table gets messy with a lot of inputs. Where you need to filter out the number of columns you're viewing. So what you can do is just type the names of the columns you like. For example, I am taking the unique ID, which is the first column, and then I am taking the well name, and then the alias, and then the X coordinate, and then the Y coordinate. And I think that will be it. Let's go ahead and click run. So xcore. So I'm missing a C in here. So as you can see, whenever I specify the column names, so I'm getting a data view or a result view from this SQL statement, or from this SQL query, I'm getting it at a data table. The nice thing about this is SQL actually provides you with a driver for Python, so you can interact with this SQL database. So let's go ahead and create a small script, Python script, to interact with database and possibly to do some plotting with that as well. So in order to be interactive with the Python database, what you need to do is to import a library called PyODBC, which is a library. I think it's provided by Microsoft, or it's approved by Microsoft. I'm not sure, but it's an official library to interact with SQL Server. So import and PyODBC. It's written like this. And then I'm going to import Plotly Express express.express as px. And then what we are going to do is we need to create a connection string. So a connection string is, I don't want you to worry about the connection string. Connection string, you can have it from your IT guys if you're working in an operator company, or if you're working in a servers company who they have access to SQL database. But it's basically a connection string is basically a string that describes you how to connect to this type of data. For example, if you click this connect button, it shows you the type of the database and the server name and the type of authentication. This is not the connection string 100%. This is part of the connection string. So I already have my connection string. So I will add it into a string. So connect string equals to, let me just go ahead and copy and paste the connection string, by the way. This is the connection string. So let's go ahead and take a look at the connection string. The first part of the connection string, this is the driver. So what's the type of the database connection you have? For example, you can just remove the SQL Server. Maybe you can add Access or any types of Microsoft connection capabilities. And then you have this server. This is the name of the server. So this is the name of the installation of the SQL installation. This is something that's fixed. It does not change unless you uninstall the software and install it back again. In this part, we have the database name. The database, you can have multiple databases on a single server. So this application, I just show you guys, this is the Microsoft SQL Server. Actually, this is called a server, a database server. It can have multiple databases. Okay, so, and you have the final part, the trusted connection. This means that you are already working with Windows authentication, so you don't need to specify any password for that. So let's go ahead and create a connection. So connection equals to pyodbc.connect, open and close parentheses, and it requires me a connection string. So connection string. So we already explained that connection string, actually, it's just a string that describes you how to connect to the data. So connection, I will just go ahead and put connection. Yes, I am already connected. You can see there is this and there is this hex, meaning that the variable of the connection is already created in the memory, so it's already connected. If you want to view the status of your connection, what you can do is just click on dot, and then you get to closed. There is a function called closed. You open and close parentheses and run this, by the way. Sorry, just without the parentheses. So what I'm doing is I am checking if the connection is closed. It tells me false. It means the connection is still open. So let's go ahead and try to pull some data from it. I'm going to import pandas. Import pandas as PD. Okay. Once the pandas is imported, pandas actually provide you with some capabilities to work with the SQL databases. So what I'm going to do is let me just define a query string to pull up some data. So my query is going to be one of the queries that I wrote in here. You just go and click copy and paste it to your query. So this is how you work with databases. You need the database client or the database server to execute your queries and to check if your queries is 100% correct, and then you port it over to Python or whatever programming language you're using. So once I have my query defined, what I'm going to do, I'm going to import the data frame or create a variable called data frame. Data frame equals to pd.read_SQL. So it requires the query. So I'll pass my query, and then it requires the connection object. So this is the connection object. Now, if I print the data frame, now this should view the results for me. You already see I already pulled a similar frame, a similar table to this using the Microsoft SQL Server. So just for comparison, it's the same data frame I am pulling in Python. What you can do with this is actually you have limitless possibilities. For example, you can change the query to import a production query or injection query and plot that. So let's go ahead and do that. By the way, you can just use this query and create maps that we already did in the previous webinar or the previous part number 1. So let's go ahead and pull some production data. So I know my production data, it's existing in a table called PRD. So this is the production data. So how to view this data? So you need to use select statement. You write select all from PRD. Click on run. So you will get all the results from the SQL database. So let's go ahead and copy this and just paste it in our query. run the query again to check if it's working. Yes, it's working 100%. You see you have the unique ID of the well. You have hours, oil, gas. Let's go ahead and do some plotting with this. I will try to create Plotly Express plots by using px.line, and then I will provide the data frame to it. So the line function is going to make use of the data frame, and then I will provide the x, which is the date. Sorry, just be careful with the the upper and lower cases because it's case sensitive. And y, I have the y as oil, so this is the oil production. Let's go ahead and click run to view the results. So I'm already generating some results. You can see this plot actually is a very messy plot because you have multiple wells on the same database. So it's just plotting everything. This is not healthy, by the way. You should not do that. So in order to just divide or groups the wells, let me use a function or an attribute called color. So this will divide the wells into colors. So my division is going to be based on a column called UID, and just run this again. Now you have much more pleasant looking chart. However, it's still messy. But however, this is basically how you go and pull some data from a SQL database. In order to view a single well, you double click on the well. In order to shut in any well you like, you just click on the well name. It already shuts in it for you. What you can do is you can just change the variable name, let's say to gas, and run this again. And you should get a plot for gas only. You can zoom any part of the chart you like. So the possibilities of using Python with SQL and to generate some workflows in oil and gas industry, it's a lot of possibilities actually. So this concludes our webinar. I'm very thankful for you guys for